At the center of our Milky Way galaxy lies a supermassive black hole known as Sagittarius A, pronounced Sagittarius A star. This black hole is the gravitational anchor of our galaxy, a massive object that influences the motion of billions of stars, gas clouds, and other celestial objects. Understanding the details of this black hole gives us valuable insight into the structure and behavior of not only the Milky Way, but also many other galaxies, as supermassive black holes seem to be common at the center of most large galaxies. What is Sagittarius A? Sagittarius A is a supermassive black hole located about 26,000 light-years away from Earth, near the constellation Sagittarius. It is called supermassive because its mass is far greater than that of a typical stellar black hole. Stellar black holes are formed from the collapse of massive stars, but Sagittarius A has a mass that is millions of times greater than our Sun's, placing it in a unique class of black holes found at the center of galaxies. This black hole cannot be seen directly because light cannot escape from a black hole. However, astronomers detect Sagittarius A indirectly by observing the effects it has on the nearby stars and gas in its immediate vicinity. These effects include the rapid orbiting of stars around an invisible object and the gravitational warping of space-time. The characteristics of Sagittarius A. Sagittarius A has a mass estimated to be about 4.1 million times the mass of the Sun. Despite this enormous mass, the black hole's event horizon, the boundary beyond which nothing, not even light, can escape, is relatively small on a galactic scale. The radius of its event horizon, also known as the Schwarzschild radius, is about 17 times the radius of the Sun, or roughly 24 million kilometers, which is about 15 million miles across. The black hole is surrounded by a swirling disk of gas and dust called an accretion disk. As material spirals inward, it heats up due to friction and gravitational forces, emitting X-rays and other forms of radiation. These emissions give us valuable information about the black hole's size, mass, and surrounding environment. Sagittarius A is relatively quiet for a supermassive black hole, meaning it's not actively consuming large amounts of matter. Some supermassive black holes in other galaxies are much more active, pulling in vast amounts of gas and producing enormous amounts of radiation in the process. These are called active galactic nuclei, or AGN. Sagittarius A occasionally flares up when small amounts of gas fall into it, but overall, it's considered a dormant black hole compared to its more energetic counterparts in other galaxies. The formation of Sagittarius A. The exact origins of Sagittarius A are still a topic of research, but it is generally believed that it formed early in the Milky Way's history, around the same time as the galaxy itself, more than 10 billion years ago. The leading theory is that the black hole grew over time by accreting gas, dust, and even other smaller black holes. As the galaxy formed and evolved, Sagittarius A likely played a key role in shaping its structure. It's important to note that supermassive black holes like Sagittarius A do not form from the collapse of a single star, as is the case with stellar mass black holes. Instead, they likely grow from a combination of processes, including the merging of smaller black holes, the accretion of gas from the surrounding galaxy, and possibly even the merging of galaxies themselves. Some scientists also believe that supermassive black holes may have formed directly from the collapse of massive gas clouds in the early universe, but this is still speculative. Impact on the Milky Way galaxy. Sagittarius A serves as the gravitational center of the Milky Way, around which the entire galaxy orbits. The stars and gas in the Milky Way move in elliptical orbits around the center, and the gravitational pull of Sagittarius A helps to keep the galaxy's structure intact. The black hole's immense gravity plays a stabilizing role in the inner regions of the galaxy, particularly in the area known as the galactic bulge, where stars are densely packed. Stars that are relatively close to the black hole, within a few light-years, experience strong gravitational forces, causing them to move at incredibly high speeds. Some of these stars, known as S stars, have been observed orbiting Sagittarius A in highly elliptical paths, sometimes taking only 16 years to complete an orbit. For comparison, our Sun takes about 225 million years to orbit the Milky Way once. While Sagittarius A exerts a massive gravitational influence on nearby stars, its impact decreases as you move further away from the center of the galaxy. The stars in the outer regions of the Milky Way are more influenced by the combined gravitational pull of all the matter in the galaxy, including dark matter, rather than the black hole alone. One of the most fascinating aspects of Sagittarius A is that it does not suck in everything around it. While objects that come too close to the event horizon are pulled in, most stars and gas remain in stable orbits far from the black hole. The spiral structure of the Milky Way is not directly caused by the black hole, but by the complex gravitational interactions between stars, gas, and dark matter. The spiral arms are density waves, where matter tends to clump together and form new stars, creating the iconic spiral pattern. Why do stars move around it in a spiral? The stars in the Milky Way don't orbit Sagittarius A directly in a spiral fashion, but rather follow elliptical orbits around the center of the galaxy. The spiral arms we see in images of the Milky Way are not fixed structures, but rather regions of higher density, where stars are forming more frequently. These spiral arms are essentially density waves, and stars move in and out of these regions as they orbit the center of the galaxy. While Sagittarius A exerts a strong gravitational pull, the spiral shape of the galaxy is more influenced by the overall rotation of the galaxy and the gravitational interactions of all the matter in it: stars, gas, dust, and dark matter. The rotation of the galaxy creates these spiral density waves, and the stars in the galaxy move through these waves as they orbit the galactic center. The supermassive black hole's role in galactic evolution. Sagittarius A likely played a significant role in shaping the evolution of the Milky Way, especially in its early stages. Supermassive black holes are thought to regulate the growth of galaxies through a process called feedback. When a supermassive black hole is actively consuming matter, it releases huge amounts of energy in the form of radiation and jets of particles. This energy can heat up or blow away gas in the surrounding galaxy, slowing down star formation or even halting it temporarily. While Sagittarius A is relatively quiet today, there is evidence that it may have been more active in the past. Observations of X-rays and gamma rays from the galactic center suggest that Sagittarius A underwent periods of more intense activity, possibly triggered by interactions with nearby stars or gas clouds. These flare-ups may have helped shape the Milky Way's structure and regulated the rate at which new stars formed in the central region. What kind of star was it before? Supermassive black holes like Sagittarius A did not form from a single star or even a group of stars. Instead, they grew over time, likely through the merger of smaller black holes and the accretion of gas and other matter. This process would have started early in the history of the Milky Way, possibly more than 10 billion years ago. The exact mechanism by which Sagittarius A grew to its current size is still under study, but one theory is that it may have formed from the collapse of a massive gas cloud in the early universe. Another possibility is that Sagittarius A grew by merging with other black holes during the formation and evolution of the Milky Way. Over billions of years, it would have continued to grow by accreting matter, including gas, dust, and possibly even entire stars.